friends, welcome back to Math at Home with Miss Berko. Right now, if you don't have a piece of paper and pencil in front of you, pause this video and go grab it because we are getting ready to work on some word problems and you will need to show your work. Write down questions and comments and observations. Today's lesson is a little bit of a doozy, but I believe in you and I have your back. But in order for you to be successful, you're going to need a piece of paper and a pencil. All right, welcome back. So today we are going to solve word problems. Now these word problems might ask you to find the area, they might ask you to find the perimeter, and they might also just ask you to find the side lengths. We are going to have to figure out what the word problem wants us to do first. Now remember, area is, we find the area by counting the squares inside. We find the perimeter by looking at the measurements on the outside of a shape. So if I said, what is the perimeter of, So if I said, what is the perimeter of my whiteboard? We have to add up the lengths of all four sides of my whiteboard. And a side length is just the measurement of one side. It could be this side, it could be that side, any one of them. And when you hear the word dimension, that just means size. So that's a few things you need to remember. Now also, let's go back and review what we know about rectangles and squares. In a square, all the sides are the same length. So if we know one side in a square, we know the length of all the sides. And we know in a rectangle, the opposite sides are equal length. So hold on to that information. Now, before I show you any word problems, I want to give you 3 suggestions. Whenever you see a word problem, read it carefully. Read it out loud so you really hear what it's asking you to do. Also, read it more than once. If you're like me, you need to read it 3 times. I'm a teacher, but I still needed to read these word problems a couple of times to understand what in the world are they saying. Number 2 is highlight, underline, keywords. We're identifying keywords that will give us clues that will guide us to solve the word problem. And then the 3rd step, most important step, is draw a picture. Drawing a picture will really set you up for success. All right, let me show you the first word problem we're looking at. Let's read it together. By the way, there might be some familiar names in here. I already underlined keywords, but right now we're only focusing on what the word problem says. All right, let's do it. Miss Berko made 16 brownies in a square pan. The brownies are 2 inches by 2 inches. What are the dimensions of the pan she used to bake the brownies? All right, let's read it one more time. Miss Berko made 16 brownies in a square pan. The brownies are 2 inches by 2 inches. What are the dimensions of the pan she used to bake the brownies? Now, we went through step 1. We read this very carefully. Now let's identify keywords, and I'll show you why I underlined certain things. I'm going to stick this over here. I'm going to move you closer and we're going to get started. While I'm underlining keywords, feel free to write them down, okay? Awesome. Let's get started. Here we go. All right, so I underlined 16 brownies because that's important. I need to know how many brownies I will cut up to share with my friends, which is you, in a square pan. I already know the shape that I am dealing with. Awesome. The brownies are 2 inches by 2 inches. This tells me the size of each brownie that I will give to my friends. I'm adding that in because I love sharing everything I bake. So now let's look at our question. What are the dimensions? Remember, dimensions means size of the pan that I'm using to bake the brownies. So I made 16 brownies in a square pan. Each brownie is 2 inches by 2 inches. So 2 inches by 2 inches just means that one side of the brownie is 2 inches and the other side of the brownie is 2 inches. All right? What are the dimensions? What is the size of the pan? So, now we need to ask ourselves, are we looking for the area, the perimeter, or a side length? Well, if I'm looking at the size of the pan, I don't need to know what's inside of the pan. I'm looking at the size of the actual pan. And it's not asking me to add all the sides. So nope, not perimeter. I'm just looking at the side length, the sizes of each side, the dimension. So we are going to figure out the length of each side. But we're in luck because we are dealing with the square. So if we can figure out the size of one length, we will know them all. All right, so let's draw a picture. Right now on your piece of paper, draw a square pan, square brownie pan. By the way, I like to use square brownie pans more than rectangle pans. So I like this word problem. Now, I know that there are 16 brownies in there, so I need to draw 16 brownies. And I know that if I draw 4 columns here and 4 rows, that gives me 16 because, well, that is not looking like a square. Let me fix it real quick so I don't confuse you. There. So we know that there's 16 brownies in here. Let's double check our work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 brownies? OMG. I think this is our area, actually. Aha! Cool! Area. There. See? Ta-da! That's our area. 16 brownies. But we need to find out the length of each side. So if one brownie is 2 inches by 2 inches, then this brownie is 2 inches by 2 inches, and this brownie is 2 inches, and this brownie is 2 inches by 2 inches. They're all 2 inches by 2 inches because they're squares. So now let's find the length of this side. All right, so you can do this a couple of different ways. You can add up all the 2's. You can count by 2's. So let's do that. Let's count by 2's. 2, 4, 6, 8. You can count the squares inside right here. 1, 2, 3, or not inside, on the outside. We're not counting the squares inside. No, 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 no. 1, 2, 3, 4. But there's 4, and we have to multiply them by 2. 4 times 2 is 8. So we're still getting the same answer. So if this side is 8 inches long, let's see if this side is 8 inches long. 2, 4, 6, 8. Woohoo! So this side must be 8 inches long, and this side is 8 inches long. Don't forget your inches, because we're not counting marbles. We're not counting brownies. We're counting how long the brownies are. We're counting their length. So now we can answer our question. What are the dimensions of the pan to bake the brownies? And here's the way you write a dimension. You say 8 by 8 inches. You tell the reader the answer by saying the pan is 8 inches long by 8 inches wide. All right, so this was answering the side length question. Now we are moving on to a different word problem. So I'll give you a clue. We're not going to do another side length one. So now, before I read it, I want you to think about, could it be an area one or could it be a perimeter one? Here we go. Mr. Henderson's dog Sparky is 24 inches long. One side of Sparky's rectangle doghouse is 36 inches long, and the other side is twice as long as Sparky. What is the distance around Sparky's house? Whew, let's read that one more time. I'll read it slower so you can really hear what it's saying. Mr. Henderson's dog Sparky is 24 inches long. One side of Sparky's rectangle doghouse is 36 inches long, and the other side is twice as long as Sparky. What is the distance around Sparky's doghouse? All right, we read it carefully. Now it's time to identify key words. All right. In the classroom, I would have your highlighters ready so you can underline with me. But right now, you're just going to double check my work while I'm underlining for you. So we have Mr. Henderson's dog, Sparky. We know that Sparky is 24 inches long. This is important. One side of Sparky's rectangle doghouse, this will give me a clue of what picture I'm drawing, is 36 inches long. So we already know the length of one side. And the other side is twice, right here, twice as long as Sparky. We know how long Sparky is. So the other side is twice as long as this. What is the distance around Sparky's doghouse? So this is our question. What is the distance around Sparky's doghouse? Remember that distance is measuring, that perimeter is measuring the distance around something. So this question is asking us to find the perimeter. We're not looking at what's inside of the doghouse. We're looking at the size around the doghouse, distance around. So we are focusing on perimeter. And perimeter, we add the lengths, the side lengths together. Okay? All of them, all four. Not two. Okay? Don't forget, you need 4 things to add. So now we're going to draw our picture. I'm going to erase this for now. We already know that we are solving for the perimeter. So let's draw Sparky's doghouse. It's a rectangle, not a square. So the sides are not equal length, but opposite sides are equal length. So let's see. One side is 36 inches long. The other side is twice as long as Sparky. So if Sparky is 24 inches, we need to find what's twice this. You can add 24 plus 24, or you can do 24 times 2. So 24 plus 24 is 8, 48. 2 times 4 is 8. 2 times 2 is 4, 48. All right, so the length of this side is 48 inches. So if the length of this side is 48 inches, the length of this side is also 48 inches. If the length of this side is 36 inches, the length of this side is also 36 inches. So to find the perimeter, we need to take all of these lengths and add them together. And that's what we're going to do. Now we are dealing with big numbers, people. So I'm going to show you a way that I like to do to add big numbers. So first I'm going to take 36 plus 36. 6 plus 6 is 12. 3 plus 3 is 6. Plus 1 is 7. And then I'm going to leave that for a second while I add 48 plus 48. 8 plus 8 is 16. 4 plus 4 is 8. Plus 1 is 9. We have 96. 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, just double checking my math. Now I'm going to add these two numbers together. So the reason why I broke it up is because if I were to line all 4 numbers up at once, it would overwhelm my brain. But now I can add 72 to 96. And 6 plus 2 is 8. 9 plus 7 is 16. So the perimeter is 168 what? Marbles, turkeys, inches. We are dealing with inches, people. Don't forget to write in inches. That was a pretty simple one. The perimeter of Sparky's doghouse is 168 inches. All right, while I'm erasing this work, we have one more word problem to look at. I want you to take a deep cleansing breath while I'm erasing and prepare your mind for what's to come next, because it's a little tricky, but don't worry, I have your back. So we already looked at a side length problem, we already looked at a perimeter problem, and there's one more problem left. I'll let you figure out what it could ask us to solve, okay? But first, let's read it carefully a couple of times. Miss Simmons has a piece of fabric that is 4 feet wide and 6 feet long. How many squares of fleece fabric that are 1 foot wide and 1 foot long can she cut from the fabric? Let's read it one more time. Miss Simmons has a piece of fabric that is 4 feet wide and 6 feet long. How many squares of fleece fabric that are 1 foot wide and 1 foot long can she cut from the fabric? Okay, now we are going to identify our key words. So right now I want you to think about, what would you underline? What would you highlight? What do you think is important? And see if it matches with what I do. Come on closer. Okay, so Miss Simmons has a piece of fabric. Fabric is material, like this is fabric, that is 4 feet wide and 6 feet long. How many squares of fleece fabric? I can cross off this extra word because fleece describes the fabric. That means it's made out of really soft material that are 1 foot wide and 1 foot long. So this tells us the size of each piece of fabric. So when I made my brownies were 2 by 2. Miss Simmons' squares are 1 by 1. So forget the 2 by 2 from the brownies. We're focusing just on the 1 by 1. All right. So now our question is, how many can she cut from the fabric? How many pieces can she cut from the fabric? So let me give you a clue. If we're counting the squares inside, what do you think we're solving for? Area. If you thought area, good job. So now it's time to draw our picture. Let's draw the piece of fabric that Miss Simmons has. All right, so we know that the fabric, I want to make sure I draw a really good picture so you can see exactly what's happening. So the piece of fabric is 4 feet wide and 6 feet long. So let's label our picture. 4 feet wide, don't forget your units. They're not stinky feet, they're feet as in a measurement. And 6 feet long. Length and width. All right. So, in order to find the area, what do we normally do? We multiply one side by the other side to find the squares inside. So, right away, let's take our 4 times our 6. 4 times 6 is what? 24. So that is one way we can solve for how many squares inside, because they're 1 by 1. So let's draw our squares and count them to double check our work. So there's 6 columns here. There's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we need to draw 4 rows. There's row 1, there's row 2, there's rows 3s and 4s. So let's make sure there's 24 squares inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there's 24 squares inside, and our question is asking, how many squares of fleece fabric that are 1 foot wide and 1 foot long can she cut from the fabric? So check it out. This is 1 foot wide and 1 foot long. It's a square. Even though our big shape right here is a rectangle, all of these have to be the same size because they're squares. So she cut 24 pieces. 24 pieces. So we can also say that the area is 24 pieces, but that question isn't asking specifically for the area. It's asking how many squares of fleece fabric can she cut. So when you're answering, remember, you're going to write 24 pieces. Just writing 24 is not enough. There's a lot of information missing if you leave out your label. Okay, I know this was a lot of information, but I'm really proud of you for making it this far. If there was anything that wasn't clear, go ahead and email us with questions. All right, I hope you're enjoying your week. See you soon.